Okay, so this is chapter 5, identifying good measurement. Just a little review first, just connecting these two concepts of operational definitions and conceptual variables. There are different ways that you could operationalize a particular conceptual variable, like a gender identity. You could measure that by having people self-report their gender identity, or you could have a researcher observe the sound of the person's voice on a phone interview and guess what their gender is. You may argue one of those might be more reliable, more valid than the other. Sometimes it's clear that a certain way to operationalize is probably not as good. Sometimes it just depends, and there are multiple ways that a measure could be validly measured, or a variable could be validly measured. Okay, so just to kind of review what we've talked about previously about what those two things are. Okay, so there are three different kinds of measures, three categories of measurements that they typically fall under. The measurements typically fall under self-report. So think of questionnaires, interviews, having people just describe something. Very common. Of course, there are some limitations to this, and some particular groups of individuals that this just isn't going to work for, like babies who can't talk yet. Observational measures. This is where you're watching behavior and recording observable behaviors. How often somebody smiles, how often somebody talks, for example. Physiological measures. This is, think of like brain scans and blood tests, measuring how much hormone, what levels of a hormone are in someone's blood, how much the brain is activated in response to some particular stimulus, those kind of things. Okay. There are different scales of measurement that are used, so variables are going to fall into different types. The two big categories are categorical and quantitative. Okay, so categorical, think of categories. Sometimes it's called qualitative variables. So this is things like eye color, gender, nationality, the type of phone somebody uses. Okay, you might assign numbers to these, like a zip code or a phone number, but this isn't really numbers. Nothing that you actually do math on, besides just counting how many people fall under certain types of categories. You can still run statistics on this kind of data. You just use different types of tests. Let's see, quantitative. There are three types of quantitative variables. So this is actual numbers that you can do math on. Ordinal. This is rank order. Okay, so these numbers are meaningful in that they indicate rank order, but like first, second, third place in a race. However, the distance between 1 and 2, 2 and 3, numbers-wise is equal, but it may not reflect actual equal distance between those two ranks. So first place might have been very far ahead of second, but second and third were really close together, but they still are just ranked 1, 2, and 3. Okay, so going to the racing example, you could have you could measure a time, and then that would be like a ratio variable. Things like height. This is distance does matter, and there's also a true zero. Sometimes you'll have where distance matters, but there's no true zero, and that is things like IQ score, shoe size, and then a Likert scale. Okay, so you'll see all of these across psychological research. Just need to have an understanding of what each of them is. Okay, so let's talk about reliability. This is one thing that you need to have in order to have a valid measure. There are three kinds that we'll we'll discuss test retest reliability, inter-rater reliability, and internal reliability. When you think of reliability, it's pretty similar to how we use this term in common language. There's consistency. Okay? If someone's reliable, then that means they are consistent in doing their job. Okay? Test retest reliability, that's when if you use the same instrument to measure something on the same subject twice, like an IQ test, time 1, time 2, then for the same subject it should be about the same both times. Maybe it's going to wiggle a little bit, but if it's a reliable measure, then it's not going to be a big difference between those two. Inter-rater reliability, this is if you have different raters of a certain behavior, or observing a behavior, or maybe measuring something like head circumference, then if there's good inter-rater reliability, then it doesn't matter who does the measurement. It always turns out to be about the same. Okay. Internal reliability, so that's like within a given survey, if there's different questions that I'll ask about the same thing, then you should, if they get consistent responses, like people, if you ask somebody how happy they are and how joyful they are, or asking the same question in several different ways, if the ratings are similar, then there's good internal reliability or internal consistency. Okay. You can use scatterplots to evaluate this. They're a good way to visualize reliability. So here are the just some fictitious data on 4 people, and their head circumference was measured by 2 different raters, and you can see that it's a little bit different. Now, I might be concerned about this because head circumference should probably be more reliable than this, but you can see that it's pretty close, at least. They're not way off. Okay, so whatever you're using to do your head circumference, and whoever your people are, your researchers that are doing it, there seems to be pretty good reliability, or at least the closer they are here to being on the line, the better the better your reliability. Okay. Whereas here is Peter versus Mark. If they're far away from the line, rather than being tight close up to it, then there's probably some disagreement. So maybe you need to check and make sure that both Peter and Mark are on the same page as far as how they're giving these ratings. In this case, it doesn't look like they are. Okay. If you use, if you want some numbers rather than just kind of looking at the plot, the correlation coefficient gives you a measure of how tightly the points are grouped around the line of best fit, if you will. Okay, so the line that best fits these points. If they're really tightly clustered around there, then it's going to have a higher R value. Now, this can be both positive and negative, right? But if it's closer to 1, if it's further from 0, either 1 or negative 1, then it's a stronger relationship and there's greater reliability. Okay. Cronbach's alpha is a number that is often computed on multiple correlation coefficients. Okay, so here's an example of what internal reliability looks like. Okay, so if you correlate the ratings on item 1 versus item 2, the conditions of my life are excellent, and item 3, I'm satisfied with my life, you would anticipate that those are going to be correlated if there's good internal consistency. You would expect that there's going to be not as high of a correlation coefficient. With this, I'm fond of polka dots. Okay? That shouldn't have a very strong relationship with how satisfied somebody is with their life. Okay? And you can see that that's the case. If you can compute the average of these correlation coefficients, and then Cronbach's alpha also takes into account the number of items, you can get Cronbach's alpha. Okay? And if it is above 80, then it's got a good internal reliability. So you'll come across this number alpha in the literature as researchers try to validate scales that they use. Okay, like the satisfaction with life scale in this case. Okay, face validity and content validity. These are subjective ways to assess validity. Okay. If a measure is face valid, then it just subjectively looks like what you want to measure. Okay. If you want to assess this, you might want to just talk to some experts. Say, hey, I'm building a survey on life satisfaction. You know basically what kind of things people should say or respond when given a survey if they're satisfied with their life. So does this survey seem to capture that really well? Or if somebody's depressed, or if they're anxious, what kind of things would you expect them to respond in a survey? Or what kind of questions would really get at that? Okay. Content validity. This is that your scale is comprehensive, okay? That it captures all aspects of happiness or intelligence or depression, okay, whatever your conceptual variable is. Depression is probably going to be, it's going to have more facets than simply do you feel sad, okay? So you want to make sure that you capture that based on the definition of your conceptual variable. Okay. Criterion validity, this is where you correlate it with key behaviors. Okay, so if there's behaviors out there that you would expect to correlate with, like if there's an aptitude test, maybe this is aptitude in doing sales, well, then you should expect that to correlate with how much money somebody makes when doing sales. Okay, again, here's the spread out pattern that indicates lower criterion validity versus this, which they're very tight. Okay. You can also use a known groups paradigm where, so the BDI, the Beck Depression Inventory, is an actual scale that's used in psychological research, and to verify that it's a good scale for detecting depression and measuring severity of depression, you'll want to compare it to psychiatrist judgment. If a psychiatrist says this person is depressed versus this person is not depressed, you should expect a higher BDI score in the depressed group. Okay, and you can get even. So this would be, does it detect well depression versus not depression, and then similarly depression severity. You should see a higher BDI score for patients who are rated as having higher severity of depression. Okay. Convergent and discriminant validity, these are kind of two sides of the same coin. Basically, just convergent validity is, if there's good convergent validity, then you should see a high correlation with a similar measure that measures the same thing. Okay, so BDI and CESD, these are both scales that are used to measure depression severity. So you would expect the ratings on these two scales to correlate, have a strong relationship to each other. Now, you might argue that this doesn't look very good, but it definitely looks better than this. It's rare that you see scatterplots that are really tight, like some of those examples I showed you. But here, divergent validity, it's the opposite. Okay, so the BDI score, you also don't want it to just correlate with everything. So here's physical health problems, and you're saying that there's not much of a relationship with that. So that's good. You want it to capture what you want and not much else. Okay. Just a brief note about reliability. Remember, reliability is about consistency. Validity refers to how well a measure is associated with something else. How well does it actually capture what you want? So something could be reliable, meaning that it's consistent, but it might be wrong, right? So like a bathroom scale, if you step on it and it says you weigh 20 pounds, every single time, if it consistently tells you that, then it's reliable, but it's probably not valid. Okay? So reliability, you got to have it to have a valid measure, but it's not sufficient. Okay? I'll let you dissect this chart. This is just kind of a nice thing that's in your textbook to kind of put all these concepts together in a nice flow chart. So